Right, here is a very good examination question on inverse functions. Once again, be careful with this type of graphs because when you look at them from a distance, they will look like it's an exponential function. So you have to look at the equation carefully. My equation here is f of x is equal to ax squared. So it is a parabola. Now, the sketch is given below. The point minus 6 minus 8 lies on the graph of f. Calculate the value of a. So, quickly, number 3.1, I can find the value of a using substitution. So, I have to substitute the coordinates that are there, minus 6 minus 8, into the equation. So I must substitute minus 6 minus 8 into the equation ax squared. That will give me the value of a. And I must know in general, if you are given coordinates on the graph, those coordinates can be substituted into the equation of that graph to find anything that may be missing there. Number 3.2, determine the equation of the inverse. So this one as well is a particular method. There can be no reason to get it wrong. We swap x and y, that is your first calculation. Then after that, you make y the subject. Basic algebra, swap x and y, then after that you make y the subject. Then number 3.3, write down the range of the inverse. Very much interesting. Now for this one, we need to know that the domain of the function leads us to the range of the inverse. The range of the function leads us to the domain of the inverse. So in this case, if you look at this graph, the domain for this function, remember, domain means left to right. Where does the graph start and where does it end? So the domain, the graph starts from the negative side and it ends at 0. So the domain for this graph is from negative infinity to 0. This is the domain of f. So from the domain of f, we can get the range of the inverse. The range of the inverse will be y is from negative infinity up to 0. This will be the range of the function. You need to know how those two are connected to each other, the domain and the range of the function and the domain and range of the inverse of that function. Number 3.4, draw the graph. We have explained this one. The main idea is that if your graph is going to the positive side, that's my graph for f, then I must know that the inverse of the graph will go to the positive side as well. They must face same direction in terms of their signs. So the inverse will also face the positive side. That's how these graphs work. If I have got my graph going to the negative side, then I must know that the inverse for this function will also go to the negative side. That's how these graphs work. In this case, however, be careful that the graph is starting from 0, 0, which means the inverse is the domain is limited. You're not drawing a complete graph, but you're drawing a restricted domain graph. Number 3.5, reflection along the line y is equal to x is the one that produces the inverse. So that's what we do in number 3.2. I don't know why this question is like this. In number 3.2, you are effecting the reflection along the line y is equal to x. Then reflection along the x-axis. If you are reflecting along the x-axis, f of x will become negative f of x. In other words, you change the signs of the equation. That is what we do in order to reflect. So I advise that for number 3.5, go through the different types of reflections and transformations, because we do not know what they are going to ask you in the examination. These are the basic general ideas that are in this question. Once I figure them out, I can go ahead and answer my question with no problems. So here are our answers. Now we know what to do already. Number 3.1, to find the value of a, we definitely use substitution. The coordinates that are given, the point P, the coordinates of point P, the first value goes into x and the second one into y. So that allows us to calculate the value of a. This is a normal simple equation. A is equal to 2 over 9. Number 3.2, we have explained that you express your equation in terms of x and y. Swap x and y. So in place of y, I'm going to have x, and in place of x, I'm going to have y. So that means x is equal to 2 over 9y squared. Then from there, we make y the subject. So carrying on, I divided both sides by 2 over 9, or you can simply multiply here by 9 over 2 and multiply here by 9 over 2, so that you can get rid of this fraction to get y squared is equal to 9 over 2x. Then to get rid of the square, we definitely take the square root of both sides, and that will make y the subject, and therefore our equation is complete. So this is how to determine the equation of the inverse. Remember, our equation is y is equal to 2 over 9 x squared. And the method we are using is that you swap x and y, then you make y the subject. You can also make x the subject. So if I divide here by 9 or by 2 over 9, and I also divide here by 2 over 9, this will give me 9 over 2y is equal to x squared. Then I square root both sides. Now I have 9 over 2y, the square root of 9 over 2y is equal to x. Then you swap x and y. So if I swap x and y, what I get now is the inverse of the function. Put y in place of x and x in place of y. You get the square root of 9 over 2x. This is the equation of the inverse. So it doesn't matter which one you do first. You can swap x and y and make y the subject, or you can make x the subject and then swap them. Then the number 3.3, we've explained this one. The range is from negative infinity up to 0. That answers 3.1, 3.2, 3.3, no problems at all. Let's look at the next one. 3.4 and 3.5. So we need to draw the graph. This must not give us any problems. We have explained this several times. The coordinates of P minus 6 minus 8. The question says draw the graph of the inverse and indicate coordinates of a point on the graph different from 0, 0. So the coordinates of the point on the graph that we need to indicate here are the coordinates of P after the coordinates of P after the reflection, or on the inverse. What are the coordinates of P? So remember, the inverse and its original function are a reflection of the graph along the line y is equal to x, and this reflection is achieved by swapping these coordinates xy. So the coordinate xy becomes yx to get the inverse. The coordinates xy becomes yx, which means the point given P minus 6 minus 8, this will move to minus 8 minus 6, and that is what we need to show on the graph. So if you draw your graph, you put that point in, and that answers question number 3.4. Then number 3.5, reflection along the line y is equal to x is the one that gives us the inverse. So we have already done that in the previous questions. All we are going to do now is reflection along the x-axis. To reflect along the x-axis, f of x will become negative f of x. So put in simple terms, you reflect along the x-axis by changing the signs of the equation. So we're going to have, we need the equation of the inverse. In this case, we have determined the equation of the inverse already. Y is equal to the square root of 9 over 2x. This is the equation of the inverse. So if I reflect this one along the x-axis, then the reflection along the x-axis changes the signs of the terms in the equation. There is one term only in this equation, so that one term will change from negative to positive. From 9 square root of 9 over 2x will become negative square root of 9 over 2x. That will be my answer for number 3.5. So our original equation and then the inverse. The inverse will be the negative sign. So for us to move from this original function to the inverse and then to reflect along the x-axis, that is what has brought this equation from that form up to that form. And that completes my entire question from 3.1 to 3.5, graphs of inverse function.